Jacob Kiner, presenting for the Unit 1 presentation. So, since history was first recorded, insects have probably been one of the greatest pests to agricultural crops across the world. Every country, every society has had to deal with this. And for the better half of the 20th and 21st century, one of the ways that we have attempted to deal with that is by throwing harsher chemicals, insecticides, sprays at these insects in an attempt to eliminate or at the very least dissuade them from consuming so many crops. And for a while it may have worked, but nowadays we are seeing that so many of these insects have built up resistances to this, or the ecological damage is just too great to justify using such harsh chemicals. So, in response to that, ways have been looked to more biologically counter these insects in a way that could be a bit more sustainable, a bit more effective, without the dramatic impact on the surrounding environment and possibly us consuming those crops as well. A few of these methods include the sterile insect technique, or SIT. This is a sex-linked gene that can be inserted that can either be totally lethal to all offspring, or it can be female specific, which leaves the male offspring to continue on spreading the lethal gene and continuing to eliminate that population. So by introducing these to insect populations, it can start a chain reaction that allows the killing off of majority, or at least a manageable size, of the insects so as not to affect the crops. And this process has honestly seen some success against screwworm infestations, both in North and Central America and also in Libya. Another technique known as IIT, or incompatible insect technique, which is basically similar along the lines where it's something attached to the males, but it's actually a intercellular bacteria that can render the matings infertile, so the eggs are just rendered null. However, this has a little bit of issues. While it sounds good, it has to be male specific. If females are released with this as well, it can lead to an easier resistance buildup. So it has to be male sex specific. And this can be difficult because in many insects, it's kind of hard to tell the difference, and it's even harder to just pick them up and check each and every individual one in order to create a sustainable amount to be released. So this technique is still in various degrees of success. A third way includes the BT crops, or biotoxic crops, which are engineered to express insecticidal toxins. This one, while it sounds good on paper, also needs to be careful the way it's applied, because, like we've seen before with regular insecticides, if you release too much of this crop, it just leads to the insects slowly but surely building up a better resistance to it. So we have to go back to the drawing board again and again. So a way to counter this could be either extremely high doses, which could just wipe everything out totally, but that still has still a pretty good chance to bounce back, or creating refuge areas where there are plants that are not biotoxic, where the insects can kind of continue to grow, so it slows down that quote unquote biological arms race against these. All of these need to be continually monitored as they're being used, just so we can understand the better impact and the better design to this. Personally, I'm not sure how I feel about these. Like I've said before, I've taken a lot of ecology classes like this, where we see this, where we keep trying to throw more and more problems at these, or more and more attacks at these, and the insects just keep bouncing back. And the last thing we want to do is create a bug that is so resistant, or continue a gene that is so resistant that it just renders all of our attempts null. So I think if we continue down this line, we need to be extremely careful in the ways that it's applied, and so that we don't end up stinging ourselves in the butt, so to say.